Hello, everyone. My name is Pasha Ranakosuma. Today, I'll be doing a presentation video for the OSINT investigation class. Today, I'll be doing a tech demo on the SunCalc website. So what exactly is SunCalc? Well, let me explain it before we get into it. SunCalc.org is a free OSINT tool that has been promoted by Bellingcat. It's an organization that does a lot of open source investigations, and we've also watched a documentary on them. What the website does is that it gives certain geospatial or location information depending on the time and day, and it tells you a lot about the sun and the shadows that the sun creates. It can also simulate the movement of the sun in different locations, so you can predict what the shadows will be like in different places, different times, and different days. How exactly does it work? Well, if you remember anything from geometry class, you know that if there's an object, like say a pole in the bottom picture that has a shadow, then you can measure the shadow to find out what the angle of the sun is using geometric properties, sine, cosine, tangent, that type of thing. And once you know the angle of the sun, well, we know that time is based on the angle of the sun. How can you use SunCalc in your day-to-day? If you're given a picture, you can verify what time the picture is taken at by judging the shadows and angle of the sun. And this is important because when you're doing an OSINT investigation, you never want to take any social media post at face value. You always want to be fact checking whatever you're looking at in order to be credible and in order to be transparent, which is something that is really important. So let's do a demo. This is an image that was part of a video that I shared a lot on social media. It is a bunch of people looking at the aftermath of perhaps an explosion. This was taken after an airstrike or a raid in a place called Zabid, Yemen. In Yemen, there's been an ongoing civil war with a lot of different players. Allegedly, this video of the airstrike was taken on the 12th of May 2015 at military time 1614. And so if we want to include this in any investigation, obviously with you are fact checking, and we should figure out, are these people on the scene actually truthful in saying that this happened on the 12th of May at that time? Because as we've seen before with a lot of fake news, sometimes people can repost old images of bombings and say it happened in a certain place. When we're doing stuff with the sun and shadows, we're creating a sort of a ratio, right? So obviously that man is not 5 centimeters tall, but he is in the image on my screen. And although everyone's screen might be different and he might be a different height when you measure on your computer, whether with a ruler or with like a Photoshop tool, all that matters is the ratio. And we see that the ratio between the man and the shadow is 5.67 to 9.84. So when we have that information, we go to our SunCalc website, which I'll open up right now. So this is the SunCalc website, just a brief overview. Here is the different times of the day, 0 to 24. You could slide it around and you could see the sun on the bottom moves around as well. It has a default location of Madrid or Spain. This orange line depicts, if I'm not mistaken, sunset. And this other orange line depicts sunrise. This is the sun. This is the way that the sun comes in, more or less, position of the sun. And go to the location tab here. And it was in Zabid, Yemen. Hopefully it should come up. Yep. The time it was at was May 12th, allegedly at May 12, 2015. And it was allegedly at 1614. And if you go back to my slide, the object of the object was 5.6767. Take it on. And then, so basically what the website is saying is, and Zabid, Yemen, in this alleged time, at that alleged day, these are all the stats: the dawn, the sunrise, sunset, dusk, etc., how long the sun is going to be out, all this stuff. And the important part is, if there's an object that's 5.67 tall, then the shadow should be 9.85. And that correlates almost exactly to our investigation, which means that the social media poster was correct in saying that the picture was taken at 1614 UTC. Now, what would be interesting is if it wasn't correct, then you could say, oh, that poster was a liar. And for instance, If the length of the shadow is actually 14 long, then we could say it happened at 7 o'clock. And so from there, you could sort of get a rough estimate of the time from shadows. Moving on. So what are some limitations of SunCalc? Well, if you've ever done any Twitter searching, you know that not all pictures have legible shadows, or that shadows could be obstructed, perhaps in the case of if there's a really big explosion with a lot of smoke. And it can only give a rough estimate of time. The sun doesn't necessarily move that fast, so you know you can't get it down to the minute. You could get at most to the closest half hour, and so you have to tread lightly in about how precise you're about being about things. So some questions for you guys. What other applications of SunCalc are there? And how can we use it in our day-to-day investigations? And how can we find more truths using SunCalc? But anyway, that is it for me. I hope this tech demo was useful.